So we're talking about series. Both of the next two units, which will be the rest of the Calculus BC, will be talking about series. This particular unit, you're going to just be given lots of different series, and you're going to be proving whether a series converges or diverges. And that's pretty much what you do in this whole entire unit. So first of all, let's talk about what a series is. If you have a sequence is like 1, 2, 3, 4, and so on, like we've been working on. A series is a sequence where the terms are added together. That's basically the difference. Now, when we say a series converges or diverges, what we mean is you can find the sum or you can't find the sum. So, this particular series, if it goes on forever and ever and ever, is going to diverge. Because I keep adding bigger and bigger numbers, I never get to a place where I could sort of find the limit of what the sums would be. For example, if I add the first two terms, I get a 2. If I add the first three terms, I get 5. If I add the next 4 terms, I get 9. And these sums just keep getting bigger and bigger and bigger. Okay? Now, if I had a different series, for example, this one is going to converge. And the reason it's going to converge is because the things that you're adding to it are so small that it doesn't change the sum very much. If I add the first two terms, I get 1.5. And then if I add 0.4 to it, or 1/4 to it, I'm sorry, I get 1.75. You see how much slower it is, like going towards a number? If I add the next one, I get 1.875. And see, those numbers, even though they're getting bigger, they're not getting bigger at a fast rate. So that one's going to converge. Now, I'm going to show you later, there's rules about why they converge and why they diverge, but I just wanted you to see sort of the idea behind it. Now, there's two kinds of series that you might have. There's infinite and there's finite. An infinite series is like those two that we were just looking at, that just go on forever. They don't have an ending. A finite series would be something like this that ends maybe at 50. Finite series always converge. Because you always can add up those numbers and get a sum. Infinite series are the ones that we're debating about whether they converge or diverge. Now, most of the time today, we're going to be talking about finite series. And there's only two kinds of finite series that we care about. One of them is arithmetic and one of them is geometric. We are going to talk about one finite series, which is a geometric one, and I'll sort of show you that in just a minute. So, let's look at the arithmetic finite series. Now there's a formula you need to know, and this formula says that if I want to find the sum of a certain amount of terms in an arithmetic finite series, that this is the formula. Now I'm going to show you tomorrow, there is a process, and I'll show you where that formula sort of comes from. But for now, I just want you to know how to use the formula. N is the number of terms that you're looking at, or that you're going to add together. A1 is the first term. AN is the last term. If I'm trying to add up 20 terms, AN would be A20, or the 20th term. If I'm going to add up 100 terms, AN would be A100, or the 100th term. Okay? So let's look at some examples of just the arithmetic finite series. Let's say I wanted to find the sum of the first 50 terms of the series where A1 is 3 and A50 is 150. And it's telling me these are definitely arithmetic. Sometimes you can look at them and tell, sometimes you can't. So we just use our formula. S50 equals N over 2. This is telling me how many terms I want to add, so 50 has to be N, times A1 plus AN or A50 since we're finding the 50th term. And on this you get 3825 or 3,825. That one's easy as long as they give you the information that you need. Sometimes they won't give you all the information they need. Let's say that they wanted you to find the sum of the first 99 terms of AN equals negative 3N plus 1. Alright, I know I'm going to do sine of 99 and then 99 over 2. Now I need to know what A1 and AN are. So it gives me a formula. So A1, I can just plug in the 1, and so A1 is negative 2. AN would be A99 because I need the 99th term. So you just plug in 99 and get negative 296. Negative 3 times 99 plus 1. So then you would have A1 plus A99. And I got negative 14,751. Yes, it's okay for the sum to be negative, because if I look at this actual series, it's negative 2 because that's the first term. If I plug in a 2, I get negative 5. And if I plug in 3, that's negative 9 plus 1, which is negative 8. Notice that every term I add to it is more negative, so I'm adding a bunch of negative numbers, so that's why I got a negative whenever I found the sum. Alright, the third example, let's say I wanted to find S76 for the series that looks like this. Alright, here's what I know. I know that N is 76. I know the first term, but I don't know the 76th term. I don't know what this last term is. So what I have to do is I have to use what I know about arithmetic sequences that we learned in the last unit about the sequence formula. So I'm going to find the formula for this sequence, the explicit formula. AN, alright, it looks like I'm going up by 8 every time, so it's AN, subtract 8, so that's 8N minus 2. So this is the formula for this sequence without the pluses. Alright, now if I want to find A76, I then plug in 76 for N, and I get 606, so that's the number that goes up here, and then I just work out the problem. So you do have to remember that explicit formula. We won't be using recursive really, but you do need to remember the explicit one. So I get 23,256. Those are all finite arithmetic. Infinite arithmetic will always diverge because you always are adding numbers that are always big. Alright, let's look at some geometric examples. We're going to look at geometric finite first. Again, tomorrow I'll show you a little bit about where the formula comes from a little bit. But here is the formula for geometric finite series. It's A1 times 1 minus r to the n over 1 minus r. Alright, we know A1 is the first term, n is how many terms there are. R is the ratio or the number you multiply by. So, examples for geometric. Let's say you have A1 is 3, R is 0.2, and I want to find S15. Alright, S15 is going to be A1 times 1 minus R to the n over 1 minus r. Just be really careful about this and plugging it in the calculator. If you put it in the calculator without a fraction, you do have to have parentheses around the bottom. And there are times when you're going to have negative r's, so you're going to have to put a parentheses around that part of r. Alright, so let's put this in the calculator, see what we get. and I got 3.75. And the sums for geometric, some are bigger and some are smaller. It just depends on what you're looking at. Alright, here's number 2. I want to find the sum of the first 10 terms of the series. And you know what? There shouldn't be commas. Let's hope I didn't do that on the last one. Yeah, I didn't. These should be pluses because we're adding these together or we're subtracting them. You could have plus negative there or minus 20, however you want to write it. Alright, I know it's a geometric because it looks like I'm multiplying by 2, but the signs are changing, so my R is negative 2. I know that A1 is negative 5, and you know what? I still erased that. I'm trying to find it up to the 10th term, so that means N is 10. So now I use my formula A1 times 1 minus, here's where it's important to put that R in parentheses and in parentheses on the bottom. If you put it in the calculator with lots of parentheses, there does need to be parentheses around the whole entire bottom. And I get 1705. Alright, third example. I want to find the sum up to the 20th term of this series. If I look at it closely enough, I can figure out that R is a half because I'm dividing by 2 every time. Your A1 is 1024, and your N, since I'm finding the sum up to 20 terms, is 20. So my formula is A1 over 1 minus, and I'm not using the right formula, A1 times 1 minus 1/2 to the 20 over 1 minus a half. When I plug this in the calculator, I get 2047.998. Basically, that is the finite geometric series because it has an ending. Now, there's also what's called the infinite geometric series. And with infinite geometric series, it's kind of like what I was showing you earlier. When you're multiplying, if you're multiplying by something small enough, a geometric series will converge. But if you multiply something too big, it will diverge. And it kind of has to do with the type of sequence that you're looking at. So here's the rule. If R is less than 1, then the sum of the infinite series is A1 over 1 minus R. If the sum is greater than 1, then it diverges, the series diverges, which means that it would go towards infinity and we wouldn't be able to get the sum of it. So here's examples for infinite geometric. A1 is 5, R is a third. Find the sum of that infinite geometric series. It would be 5 over 1 minus a third. Just be sure in the calculator that you put 1 minus a third in parentheses. You get 7.5. If I have A1 as a half, R is 4. On this one you don't do anything except to say it diverges since R is 4. That number's too big, so that series would diverge. If I have this series, alright, it's geometric. I can tell that R is a half because I'm multiplying by half. A half is less than 1, so we're good. we know it would converge, so we write out the formula A1 over 1 minus R. And we get 10. The last one that I have for you is 8.8, 9.68. And I'm showing you this one because I think this one's harder to figure out what the R is. The way that you can do it, if you have trouble figuring it out, is start with the second one and divide the first one. So when I do 8.8 divided by 8 in the calculator, I got 1.1. And now if I do the same thing with the next two, I got to get the same number. 9.68 divided by 8.8 is 1.1. So that means that R here is 1.1, which means this particular series diverges since R is 1.1, and I can't find that sum. Even though I could put it in the formula and get a number, I'm really not able to get what that sum would be. Alright, I have 3 try problems for you, at least one of each kind. So the first one, we have an arithmetic series, which honestly, looking at the series, you should be able to tell that it's arithmetic. And I want you to find the sum up to the 150th term. Number 2, you can tell that it's geometric. I want you to find the sum up to the 25th term. Number 3 and 4, they're both geometric, but they're infinite. And I want you to, and I'm missing something here, so I'm going to rewrite that. I want you to find the sum of the infinite series, if you can. You might not be able to on all of them, so if you can, I want you to find those sums. Start memorizing the formulas. They're very, very important.